Welcome to I/O. Today we're talking about the next frontier of Android development, AI glasses. The Android XR ecosystem ranges from XR headsets to wired XR glasses and AI glasses. Today, we will walk you through how you can extend a mobile app to work across both AI glasses and AI glasses with display. We will also take you through what's new with Jetpack Compose Glimmer, how to build with it, and finally, how you can start building and testing your apps today with the Glasses emulator. Building for AI glasses poses some new challenges for Android developers. Last December, we announced Jetpack Compose Glimmer. Jetpack Compose Glimmer is a Compose UI toolkit for building augmented XR experiences, optimized for display AI glasses. Not all AI glasses have displays, and even if they do have a display, the user may have the display turned off. But how do we build apps for AI glasses when a display is not available? That's what I will be covering today. At last year's Android Show XR Edition, we showed the prototype to-do list that demonstrated how to build a display experience for AI glasses using the Gemini Live API and function calling. Today, we'll expand on that by showing you how you might think about building a single experience that covers both AI glasses and display AI glasses. To get started, let's review a few important details about building apps for AI glasses. First, remember that your code doesn't run directly on AI glasses hardware. You define a projected activity in your mobile app, and this activity runs in the context of AI glasses. If a display is available, your Jetpack Compose Glimmer UI is rendered onto the display of the AI glasses. You can learn more about how to launch your activity onto AI glasses by checking out Build Your First AI Glasses app with Jetpack Compose and projected libraries, which you can find in the YouTube video description. Let's look at the architecture of how we will accommodate both AI glasses and AI glasses with a display. By leveraging the existing view model, we can then observe the availability of a display with the Jetpack projected library. This lets us lead with a seamless audio-only interaction when necessary or render a glanceable UI when a display is present. For our example, we will choose to implement an in-app agent using Gemini Live API and the Firebase AI Logic SDK. Building out an agentic audio experience with the Gemini Live API is the same as it is on mobile. You can check out a great example of an agentic experience as part of the AI sample catalog that is available on GitHub. Check out the Gemini Live to-do sample. There are some additional considerations to think about when building audio experiences for AI glasses when a display is not available. I'll cover a few of these next. We recommend that you provide a sign of life when your projected activity launches. This helps indicate the projected activity is running and ready to interact. Here, we are using the Gemini Live API to greet me with, "Hello, Kathleen. You have 3 list items. Ready to get started?" when the to-do app starts up. You might also think about implementing additional agentic tools to enable actions that a user might normally do via the graphical user interface. In this example, the user indicates they want to stop the session. The model executes a function call that updates the microphone state and closes the session. When the AI glasses have a display available, some of the features we discussed could come across as redundant or verbose. The Jetpack projected library provides a few functions to help you adjust the audio experience when a display is available. You can query projected device controller capabilities and look for capability visual UI. This will let you know if the current device has a display at all. The projected device controller add presentation mode change listener will let you know when the presentation mode changes. A presentation mode of visuals on indicates that the current display is on. We pass the display state into our root screen, and when that state changes to true, it triggers a recomposition. As you can see in the code here, we conditionally render the Jetpack Compose Glimmer UI or the audio experience based on the state of is display capable and are visuals on flags. If a display is not available, we will fall back to the audio first experience. Let's now look at some Jetpack Compose Glimmer UI code in action. We're declaring a list item for each item to the screen. This allows the user to check off, add, and remove items. As you continue to expand your app, you will want to take full advantage of Jetpack Compose Glimmer library. To talk you through some of those great capabilities in Jetpack Compose Glimmer, I will now hand it off to Adhi, who will take you through what's new in Jetpack Compose Glimmer.
Hi, my name is Adhithya, and I lead design for Android developer experiences. Designing UI for display AI glasses is an extremely different ballgame than designing for a phone. Why? because glasses uses an additive, transparent display. This means it can only add light and it cannot create black. What you see in your standard design tools is not how it will appear on the device. Last year, we introduced Jetpack Compose Glimmer specifically to create user interfaces for this medium. This year, we're expanding the library with more components and a refined visual language. Jetpack Compose Glimmer provides a comprehensive set of composables and building blocks optimized for the visual and interaction constraints of display AI glasses. These components are designed to ensure legibility, support touchpad input, and manage visual hierarchy. Let's briefly look at the core primitives you get today, starting with the Jetpack Compose Glimmer theme. Out of the box, Glimmer theme applies additive safe colors and legible typography, so your content is designed to maximize legibility across a wide variety of real-world environments. When it comes to font choices, Jetpack Compose Glimmer components include Google Sans Flex by default, a typeface specifically tuned for the unique display requirement of glasses. Now let's look at some of the components that Jetpack Compose Glimmer supports, starting with buttons. These are pre-wired for glasses touchpad gestures like taps and swipes. They provide clear, outline-based visual feedback you need for transparent displays. Next up, button toggles. Along with standard focused, unfocused, and press states, these have dedicated selected and unselected states to show what's on or off. They're perfect for mic and camera toggles. Next, let's talk about button groups. These allow you to provide multiple actions in a minimal footprint. You can provide just icon buttons, label buttons, or buttons with both. The button group will automatically overflow, off-screen, and scroll as you move focus. Cards in Jetpack Compose Glimmer are modular, adaptable containers that group information into single digestible unit that fully support images. Next is title chips. This component, when used in conjunction with your cards, gives better context and categorization to the content displayed. Beyond these basic primitives, we're also introducing several interactive components. These allow you to organize content with the structural hierarchy required to truly leverage the AI glasses display effectively. These include vertical list, a dynamic container with built-in scrolling and focus support for various element sizes. Stacks are designed to show only one item in a group at a time, hinting at additional items above or below. They particularly shine by allowing the user to navigate between items one at a time while masking items off-screen to let the user focus on the currently selected item. And finally, a voice input indicator to give users visual feedback when their microphone is active and in use. We built these components so you don't have to worry about the constraints of the display. You can just focus on building incredible experiences. Louis will now show you how to use some of these components in code.
When we developed Jetpack Compose Glimmer, we wanted to make it easy to build polished out-of-the-box experiences while allowing for customization and flexibility in our components. Let's look at some of the APIs for the components Adi introduced. Jetpack Compose Glimmer follows the same API principles and patterns with the other Compose libraries that you are already familiar with. Let's revisit the To-Do app Kathleen showed earlier. To build the list of to-do items, we can use a vertical list, which allows users to scroll through different items. Vertical list is used with list item, which contains a primary label, and an optional leading icon, trailing icon, and supporting label. Vertical list follows the same API shape as existing Compose APIs such as lazy column, but includes out-of-the-box support for smooth focus scrolling, and a scrim to indicate to the user whether there is more content off-screen. Notice as you swipe on the touchpad, the list smoothly scrolls and moves focus between items while scrolling. The scrolling speed is also reduced at the start and end of the list to make it easier to move focus between items. Let's now imagine you want to add subtasks to the to-dos. We can use a stack to show individual subtasks, allowing us to use most of the screen for the currently selected item. Stacks similarly follow the same general pattern for lazy components, and so the API shape should look very familiar to Compose APIs like lazy column, and also the vertical list we showed earlier. Stacks let the user navigate between cards once at a time, while masking items off-screen to let the user focus on the currently selected item. Now we need to connect the main list of to-dos with the new subtask screen we just built. When building a mobile app, you can use the Navigation 3 library to handle navigation between screens. The same is true when building an AI Glasses app. You can follow the same patterns and libraries in your mobile app for handling navigation between Jetpack Compose Glimmer screens. When the user clicks on a to-do item with subtasks, we navigate to a new nav entry with the stack. When the user navigates back, we pop the back stack and return to the to-do list screen. Let's talk about customization. With Display AI Glasses, UI customization has some additional challenges. Component surfaces are typically translucent with thin borders, so there are generally fewer pixels that can be changed. Jetpack Compose Glimmer contains a theming system with a set of colors that can be customized to match your brand. Customizing the primary and secondary colors is a good way to make sweeping changes across surfaces in your application. The primary color is typically used with icons and components such as buttons and cards. Using border colors is also a good way to accentuate particular interactive components. You can apply a border color underneath the focus highlight effect to apply some additional emphasis or semantic meaning. For example, we can use the positive color from the theme to define a button with a confirmation action. I will now pass it back to Adi to walk you through how to emulate running apps on glasses.
Thanks, Louis. So we built a journey that goes from phone to AI glasses. But how do you actually test all these experiences? More importantly, how do you test them without physical hardware? In addition to writing your code, with Android Studio, you can emulate, test, and preview glasses experiences just like you test mobile apps. First, to create a virtual device, you simply add an AI glasses virtual device, select the appropriate system image, and hit Finish. This automatically downloads and installs the virtual device on which you can emulate display glasses experiences. Next, you need to pair the glasses device to an available phone. You can do this by clicking on the Pair Glasses button in your AI glasses virtual device. When you open the pairing assistant, your installed Canary devices will appear. This automatically sets up a connection between the phone and the glasses. After this, you're ready to launch your projected activity directly on your virtual AI glasses device. After you launch your glasses app on the emulator, you can interact with your application exactly as you would with a mobile app. By tapping or swiping on the AI glasses emulator, you can simulate trackpad input. This allows you to experience firsthand how your application responds to different touchpad gestures. Finally, to test those beautiful Jetpack Compose Glimmer UI states, we use Compose previews and the ability to change environments to test your UI against various lighting scenarios. You can simulate light, dark, or busy backgrounds in Studio to ensure your UI is legible. Now back to Kathleen.
We've covered a lot today, from architecture to UI testing. But most important takeaway is that building for AI glasses doesn't mean starting from scratch. In this specific case, we are able to create these rich glasses experiences using all the existing app infrastructure we had already built. By treating your existing app's view model as the single source of truth, you can seamlessly extend your mobile app to support both AI glasses and display AI glasses using the skills you already have. When you're ready to build the visual experience, Jetpack Compose Glimmer's components ensure your UI inherently adapts to the physical world. Best of all, with the new emulator tools, you don't need a physical device to get started. You can test your display and audio-only experiences right from your desk. To help you get started building today, we've published the complete to-do list sample app, a comprehensive Figma library for designers, and updated the documentation. To get started, go to developer.android.com, download Android Studio, and start building for AI glasses today. As always, we're listening to your feedback. Thank you and enjoy the rest of I/O.